Hello, welcome. My name is Eugene. I am a lecturer in Kenya. I teach professional courses such as SCCA and CPA. My videos cover various topics found in these professional courses. The main subjects covered are management accounting, performance management, and quantitative analysis. I welcome everyone interested in learning something. Sit back, relax, and let's begin. Hello, welcome back to my channel. In this video, I will take you through set theory. Introduction. Set theory is a branch of mathematics that studies sets and the relationships between them. A set is a well-defined collection of distinct objects. The objects in a set are called elements. Sets are usually named with capital letters, for example, capital A, and their elements are listed inside curly brackets. For example, set A has the elements 1, 2, 3, and 4. To indicate the membership of an object in a particular set, we use this symbol, and for non-membership, we use this symbol. For example, set B has the elements 2, 6, and 10, then 2 is a member of set B, and 7 is not a member of set B. The cardinality of a set is the number of distinct elements in a set. The cardinality of a set A is denoted by NA. For example, set A has the elements 1, 2, 3, and 4, then the cardinality of set A is 4. Types of sets. 1. Universal set. This is a set of all the elements under consideration in a particular situation, commonly denoted as U. For example, the set of all integers is a universal set. 2. Disjoint sets. These are sets that have no common elements. For example, sets X and Y are disjoint sets since they have no common elements. 3. Subset. A set is a subset of another set if all its elements are contained in the other set. For example, set Y is a subset of set X if all the elements in set Y are in set X. Set Y is a proper subset of set X if all the elements in Y are also in X, but X contains at least one element not in Y. For example, set Y with elements 1, 2, 3 is a proper subset of set X with elements 1, 2, 3, 4, 5. 4. Empty set or null set. An empty set contains no elements. 5. Singleton set. A singleton set has only one element. 6. Finite set. A finite set has a countable number of elements. 7. Infinite set. An infinite set has an uncountable number of elements. For example, the set of all natural numbers. 8. Equivalent sets. These are sets that have the same number of elements. For example, sets M and N each have 3 elements, hence they are equivalent sets. 9. Equal sets. These are sets that have the same elements. For example, sets X and Y have the same elements, 1, 3, and 5, hence they are equal sets. Set operations. 1. The union of sets is a set containing all the distinct elements in a collection of sets. For example, the union of sets A and B will contain all the elements in the two sets without repetition. 2. The intersection of sets is a set containing all the common elements in a collection of sets. For example, the intersection of sets A and B will only contain the elements that appear in both sets. 3. The complement of a set is a set of all elements in the universal set that are not in a particular set. For example, the complement of set A will contain the elements in the universal set that are not in set A. 4. The difference of sets is a set containing the elements that are in one set but not in the other set. For example, the difference of sets A and B will contain the elements in set A that are not in set B. Properties of sets. 1. The commutative property states that the order of the sets in a union or intersection does not change the result. 2. The associative property states that the grouping of sets does not affect the outcome in multiple unions or intersections. 3. The distributive property states that the union distributes over intersection and the intersection distributes over union. 4. The identity property states that the union of a set with an empty set or intersection with the universal set gives the original set. 5. The complement property states that the union of a set with its complement equals the universal set, while their intersection is an empty set. 6. The idempotent property states that the union or intersection of a set with itself results in the same set. Venn diagrams. A Venn diagram is a diagram that visually shows the relationship between two or more sets. The diagram has circles enclosed in a rectangle. The circles represent the sets, and the rectangle represents the universal set. The Venn diagram for disjoint sets will have circles that do not overlap. For example, the two disjoint sets A and B will have a Venn diagram as follows. The Venn diagram for intersection of sets will have circles that overlap. For example, the Venn diagram for sets A and B, which have two common elements, 2 and 4, is as follows. The Venn diagram for a proper subset. The circle for the subset will be inside the circle for the superset. For example, looking at set A and B, B is a subset of set A, hence the circle for B is inside the circle for A. The Venn diagram for a proper subset and intersection of sets. Using sets A, B, and C, B is a subset of set A. Then the sets have some common elements. The circle for set B will be inside the circle for set A. Then the three circles will overlap at some point due to the common elements, as you can see in the Venn diagram. Applications of set theory. 1. Market segmentation. Customers are grouped by shared characteristics, for example, age, using set intersection and union for targeted marketing. 2. Inventory management. Products are classified into sets, for example, high demand versus low demand, allowing for better stock control and reduced inventory holding costs. 3. Data analysis and decision making. Customer behavior or survey data is analyzed to find overlaps between groups. For example, customers who bought product A and product B. 4. Resource allocation and scheduling. Jobs and resources can be categorized into sets to avoid overbooking or underutilization, ensuring efficient operations. Thank you for watching up to this point. I hope you enjoyed the video and learned a lot. Please support the channel by subscribing. Remember to like and comment. See you in the next video. Goodbye.